Who is want to join can join. Okay, so I'm live here, isn't it? Yeah, it's working. So I hope it's visible there. Yeah. Yeah. So now it's working. Hello, hello. So you can see a new avatar here. You know, it's appearing here. Isn't it? Let me spotlight it for everyone. So I think it's appearing again. Okay, so without wasting time, let us start a class. Okay. Here we go. Here, here, and Zoom share. Yes. So we are having our PPT. Okay. Okay, how is everyone? Everything is fine. So you can text it on this in the chat box. Okay. I hope chat box is there. I mean, you can just text there. We're going to start it. I've started everything. Yes. So one of the students have texted. Let me see. Good evening. Good evening. Good evening. Okay. Let us start now. So let's just the students have joined. No issue. We are free to join. Okay. So let me text on the WhatsApp there. Okay. So now let us not waste our time. You know, let's proceed. Let's do proceed. Okay. So first of all, let me check it now. Yes. So see, what we are going to do is this. We are going to solve this Neet 2021 paper. It's a previous year paper. Okay. So we are going to do what? We're going to solve this Neet 2021 paper. Okay. Let me change the star there. Let me change this star. So I'm creating my photo here again. I'm changing this. Choose virtual background. So blur will be fine. Okay. So this is fine. This is fine. Okay, let us be serious now. We have done a lot of fun. Let's change that. So I'm back here again. And virtual backgrounds. This, that. It's fine. You know? So we'll not do a lot of fun now. We have already done. So let us start with the studies seriously. Okay. Some of the students are joining. I allowed them. Okay, so let us start. Everyone is fine? Okay. So see, this is the first question. This is from Neet 2021. This is Neet 2021. Okay, it's a Neet 2021 paper, and we'll solve. Actually, Neet में क्या होता है कि Neet में number of questions which are coming are 50 total. Okay, but today we will solve 25 questions, and the next day, maybe tomorrow, we'll solve the other 25 questions. So 25 plus 25 is how much? It is 50. Okay, let us start. So this was the first question was asked in NEET 2021 physics. Okay, the question says if E, see, I will solve all the questions in depth. If E and G respectively denote what? Energy and gravitational constant, then E by G has the dimensions of what? So do you want to solve it? Anyone among you? Anyone among you, do you want to solve this question? Okay. So I'll say the answer will be what? Let us see. See, E is what? E, we know it is what? Energy. Everyone knows this thing that E is what? E is energy. Yeah. So E is what? E is, by the way, energy. Okay. And G is what? G is gravitational constant. कौन सा gravitational constant? This is what? All right, very neat here. Don't worry. G is what? G is gravitational constant. ठीक है? E is energy. G is gravitational constant. They're asking the dimensions of E by G. Okay. We know this thing. Energy क्या होता है? Energy is, let us take simple energy, that is half mv square. Gravitational constant कैसे ढूंढेंगे? We know the formula. F is equals to gravitational force between two particles is what? It is G m1 m2 upon r square. Okay, this is what G m1 m2 upon r square. That is fine. But if we use this formula, divide E by G, we'll get a formula. We'll check what is the dimension of E by G. But this will not work. Okay. So we know one more thing, that gravitational potential energy. Gravitational potential energy is given by what? It is given by G m1, okay, m2 upon r square. Okay, this is what? G m1 m2 upon r square. This is what? Gravitational potential energy. Okay. So we get here कि gravitational potential energy is this. Energy, which is gravitational potential energy, is G m1 m2 upon r. Okay. Now let us divide E by this G. This is a shortcut method. This is one of the shortcut formula for this. Okay. So we'll divide this E by G. This will be equals to m1 m2 upon r. Okay. And if you see the question in this NEET 2021 first question, they're asking E by G का dimension कितना है? What is the dimension of E by G? So you can see here the dimension will be what? M1 into M2 is what? It's masses. These are the masses. Okay. So M का dimension कितना होता है? Mass का dimension we write like this M. This is again some mass of some other body, that is the second particle, but we'll write here what? As M again. Okay. So now what we'll do, we'll divide this with R. R का dimension कितना होता है? What is the dimension of R? R dimension is length. Very good. Okay, so one of the student is saying, hello, my voice is not audible. Okay. So see, what I'll do is this. Hold on. So E by G will give me what? E by G will give me what? This is M square L minus 1. This is a dimension. And if we want to write in the basic form, we'll write T0. Okay. So we'll get the answer as M square L minus 1 T0. This is our final answer. Okay. If we see the options, M square L minus 1 T0, second is the answer. I hope everyone of you understood this thing. I hope that every one of you are able to understand this thing. My voice is fine, no? It's audible, no? What's the issue?
It's audible, sir.
Yeah. It's audible, no? Yeah. So see, this is what E by J is M1 M2 upon R square. Fine. Okay, let us proceed next. I will not change the avatar now. I'll keep my photo only here. Okay, my video here. Next is this. Yeah, good evening, good evening. So now you focus here, okay? So this question says what? Yeah, all of you have joined. Okay. So see, this is just an unofficial kind of thing only for those students who want to join. Okay, it's just for practice. Okay, if you want to learn some extra things, so this is for all those students. Okay. So yeah. Okay. So this is the question number second in the series of Neet 2021. Okay. So you can also give your own views in this channel. Also, you can comment on the channel. Also, I have given the channel. Also, you can comment on this in the chat box that sir, speed thoda dheere ya tej. Okay, sir, a little bit be slow or fast. It's up to you. Okay. So the question is this. Now I will be continuous. The question is this: an inductor of inductance L and a capacitor of capacitance C and a resistor of resistance R are connected in series as shown in this figure. So you can see this. This is what? Inductors of inductance L. This is what? Capacitance of capacitance C. This is what? Resistance of resistor of resistance R. So we can easily say this thing. This is what kind of circuit? What kind of circuit is this? Anyone? This is LCR circuit. This is what? LCR circuit. Okay. So here inductance may the potential difference is plus minus 40 volt. Capacitance may the potential difference is plus minus 10 volt. Resistance may potential difference which is given as plus minus 40 volt. Okay, it is what? Plus minus 40 volt. So they are asking you the amplitude of the current flowing through LCR series circuit is 10 root 2 ampere. So they have also given you in the question I naught max, which is the maximum current as 10 root 2 ampere. This is what? 10 root 2 ampere is the maximum current. They're asking you the impedance of the circuit, impedance of this LCR circuit. What will be the impedance of this LCR circuit? So can anybody tell what is the answer of this? Meanwhile, I'm changing my avatar. Can anyone of you want to comment on the answer? I mean, how to solve this? Anyone of you? Anybody want to solve this? So among four of these options, what do you think? What is the answer? Okay, so I'm solving. Okay, so I'll be solving this now. So what I'll be doing is this. I'll be continuous throughout the class. Okay, now I will not ask from you. What is the answer of this question? 4 options are given to you. So I'll be continuous. Okay. So here, if you see impedance, we need to find. Remember always in the series. Remember this thing in the series LCR circuit may always and always maximum amplitude current is given by what is that? Maximum potential difference upon resistance. Nahi hota. We know this thing. In the series LCR circuit, there is not just resistor, there is inductor, there is capacitor. So we'll write impedance there. This is the formula. Now, students, it is very easy. We'll just use this formula and find the answer. Okay, very easy. So if anybody is facing doubt, you can ask in between. Okay. Okay. So current will be what? 10 root 2 here. Potential difference is given as what? So how you will find this V naught value in the numerator of this formula? What's the approach? Approach is this, because all the things are in series. So we'll add all this series potential individually. So we'll say that V naught value, we'll say the V naught value will come out to be 40, 10, 40. Okay. So we'll say V naught value will be 40 plus 10 plus 40. Total answer will be what? Total answer will be 80 plus 10, that is 90 volt. Okay. So here we'll write 90 upon impedance. This is our impedance. So from this, hold on students, there is some error here. So what we'll do, we can't add directly here. Okay, so what we need to do, we need to change something. Since this is not such a simple kind of circuit, because all the circuit elements are different here. If you focus on this question, there is an inductor, there is a capacitor, and there is a resistor. अगर यहाँ पे सभी तीनों circuit element resistor ही होते, then only we'll add like this. Net potential is resistor VR1 का, VR2 and VR3. But here the individual circuit elements are different. Okay, so what we'll write? Since individual circuit elements are different, so we'll write like this: potential difference L across this plus minus. This is VC, this is VR. So इसमें कैसे solve करेंगे? How will find the V node? V node कैसे find करेंगे? So to find the V node, what we need to do is this. क्या करेंगे? What will do? Okay, so see, remember in the LCR circuit, this is L, this is R. In the series LCR circuit, remember, inductor always is forward by the from the resistor by 90 degree, and capacitor lags behind the resistance voltage by 90 degree. So this is resistance voltage, this is inductance voltage, this is capacitance voltage. Okay, so this is 90 degree here, this is 90 degree here. Now see, potential difference across inductor is given as 40 volts. So this is the potential difference across inductor. Simple, very easy. Potential difference across resistor is given as 40 volt. So this is 40 volt. And potential difference across capacitor is given as 10 volt. So you write here 10 volt. Now this is like the vector addition. This is now we'll follow here vector rules. 40 positive I-axis plus j cap, 10 minus j cap. So net will be what? Net will be plus 30 j cap. So we'll say the net will be like this, plus 30, and x-axis में क्या है? 40 I cap. Net will be how much? Net will be, we know this thing, 30 square plus 40 square. इसको ऐसे solve करोगे, so you will get the net answer, students, is 50. ठीक है? So from here we can comment the net voltage which we are getting is the net voltage which we are getting here is 50 volt. Okay, so from this we can find the impedance as 50 by 10 root 2. The answer is, students, 5 by root 2. Impedance is 5 by root 2. Now if we check the options, the answer is basically, it's not most suitable or approx, it's accurate. So the answer is what? 5 root 2. This is an answer. I hope you got the answer. Okay, so if you want to note it down, you can note it down. Otherwise, I'll give you the PDF in our doubts group. Okay, I'll give the PDF in the WhatsApp group also. I'll give the PDF in what? I will in the description link. I'll put there the link of the PDF. Okay, so you can download it via the Google Drive. Okay. So meanwhile, you see this question once again if you want, and now I'm changing my avatar here. Okay, a little bit. So I'll do what? So if I see here, let us change it somewhat. Let us do some funny. So I'll put here, which is the best one here. This is the best now. Okay. So a new character will appear automatically. Okay. So I hope it is visible to you. Now let us see the next question. So in this series of this Neet paper, this was the third question which was asked in Neet 2021 physics. Okay, you can check it out. The question is very easy. I want you to answer. Okay, it says the body is executing simple harmonic motion. Okay, with frequency n. The frequency of its potential energy will be what? Options are 4n, n, 2, and 3n. So I'm giving you 30 seconds. You solve this. Okay, I'm giving you 30 seconds. You solve this. So okay, so I am solving it now. Okay, the sound will be more clear now here. So the answer will be what? Anybody can answer if you want. See, it says here the body is executing simple harmonic motion with frequency L. So you must know this thing, that suppose there is what? Suppose students, hold on 1 second. Yeah. I know you don't like in between where there are, whenever there is a sound issues here. Okay. Yeah. So see, we know this thing. Suppose on a surface we are having what? We are having a block present there of mass m. Okay. So we know this block will execute simple harmonic motion. Okay. What this block will do? This block will execute simple harmonic motion. Okay. Under the force which is minus kx. The force is this. This is minus kx. Okay. So, and how will be the motion? The motion will be like this. It will be having maximum speed at the mean position, and when it will reach the extreme position, the force will be maximum but in opposite direction. This will be applicable for both the directions, that is maximum positive x and maximum negative x. Okay, so now let us comment on the frequency of simple harmonic motion in the position term. If we draw the graph comes like this, because we know position of a block executing under the equation SHM is given by, or executing SHM is given by this, A sine omega t plus phi. A sine omega t plus phi. Okay. Okay, that's fine. But the graph will be how? Graph will be like sine. Sine 0 is 0. Sine 90 is 1. So it will be like this. And this completes what? If you see properly, this completes one cycle. One cycle. Okay. Okay. Frequency we know already. Frequency is given by what? Frequency is given by 1 by time period. This is frequency. Okay. Fine. This is frequency of this. This is one cycle. And frequency is basically what? Number of cycles per second. Number of cycles per second. Okay. So this is one cycle. Suppose it is in 1 second. So frequency will be 1. Now we see the graph of the potential energy. We know in SHM, the potential energy curve is given by half k x square. And x is given as A sine omega t plus phi. Okay? So if you do square of this term, potential energy will come out to be what? It will be half k x square. Kitna hota hai? X square is equals to A square sine square omega t plus phi, which is initial phase. So if I draw the curve of this mathematical equation, students, see it, it's drawn here neatly. If I draw the curve of this mathematical equation, curve will look like what? Curve will look like this. It looks like this. Curve will be looking like this. Okay. If I draw the curve here, this curve will be looking as like this. It's on your screen. Okay. The curve will be this. So initially, if we see this part, this much part, if we focus this much part, now this half cycle or this half loop has went where? It has went on the top side, that is in the first quadrant. This has went in which direction? It has went in the zone of first quadrant. Okay. So we say here this, ki if initially the frequency was, see, this is due to what? This is due to the time period t. This is due to what? This is due to time period t. Suppose the time taken is t, capital T. Now, if this downward portion is turned up, I will say now the time period is reduced by what? It is reduced by t by 2. If we know the formula of the frequency is 1 by t. If time period is reduced by 1 by 2, the frequency will be doubled. Okay, the frequency will be what? Doubled. So we'll say frequency will be here twice of f now. Okay, frequency will be what? Frequency will be twice of f. So from here, See, don't create sound in between. Frequency will be what? Frequency will be twice of n. So we can say like this, we can make a statement now. What's the statement is? Statement is this. If particle is executing, simple harmonic motion, okay, with frequency f, then potential energy of SHM का frequency जो होगा वो होगा twice of f. Here it is given as n, so final answer will be twice of n. Okay, I hope you got the answer. I hope students you got this answer. Is it fine?
Yes, sir.
Okay, good. So let us choose different background again. Let us change the background. Okay, now let us proceed. Next question. So fourth question here, okay. It says, this is also from the Neet only. The complete paper is from the Neet. I told you in the beginning only, okay. It says a thick current carrying cable of radius r carries a current I, capital I, uniformly distributed across its cross section. The variation of the magnetic field BR, it means B, the magnetic field intensity, which is dependent upon the radial direction from the axis. BR means what? Where R is what? The radial direction from the axis. This is the radial direction perpendicular to the axis. Perpendicular to the axis. Okay. So they're asking the variation of this. Remember always that if you have studied, that's fine. Otherwise, I'm giving you the formula here. The formula says like this, that magnetic field intensity for distance r, where r is between the inner radius and the external radius. Suppose you are having a coaxial wire. Coaxial means what? The wire which is having the common axis and the different cross-section radii or different cross-section areas like this. Okay. Suppose internal is A and external is B. So if you need to find the magnetic field intensity between this, okay, or it's internally this, okay, it comes out to be what? The magnetic field intensity comes out to be, remember always, it is directly proportional to what? R. Remember, it is always directly proportional to R. It is something like this, mu naught magnetic field density. Okay, this is current density, J is current density, R by 2. This is for internal portion of the axial wire, okay. And if you need to find magnetic field intensity, which is beyond the material of the wire, that is at any external zone. Suppose you need to find here the magnetic field intensity, where this distance is greater than both of the radii, even the B, okay. So we'll say for this, the magnetic field intensity comes out to be inversely proportional to R. Remember this, both the formulas. Remember both of these formulas, okay? I mean, both of these relations. So from this, we can make a graph. Graph says like this, that when the radius is in the approach or in the periphery or at just the touching point of the external radius, the magnetic field varies directly proportional to R. It is like y equals to mx, no intercept, intercept 0. So we'll say it is y equals to mx like this, magnetic field intensity with R. The graph will be like this up to what? Up to the touching point of the periphery, or the point where it touches the periphery, external radius periphery. That is where R becomes capital R, the most maximum R. Here it is equals to B. Then when we just go beyond this capital R or B, what's going to happen? The magnetic field relation changes. Now the magnetic field changes with a relation that is inversely proportional to R or directly proportional to 1 by R. And we know the graph of 1 by R is like what? If this is y equals to mx, this will be like y equals to 1 by x. So it will be like this. It will not touch the ground, by the way. It will not touch the x-axis, by the way, but it will go like this. Okay? So this is the graph, and this is our solution. Now, if we match 4 options above, you can see here the best suitable graph. This is not. Let us see the positive thing. So this is the answer. Because up to this portion where R becomes capital R, this is B directly proportional to R, Y equals to MX. And this is B inversely proportional to 1 by R, that is Y equals to 1 by X. Okay? This is the answer. I hope it's clear to you, students. I hope this option is clear to you. Is it fine? I hope this option is clear to you. Okay? Yes, very good. Very good, very good. Let us move next. Fifth question. Let us go with the fifth question, okay? So it says here a nucleus which is having the mass number 240. Okay, it's also a question from the nuclear physics chapter, by the way. This is from a nuclear physics chapter, okay? It says a nucleus with mass number 240 breaks into 2 fragments, each of mass number 120. The binding energy per nucleon of the unfragmented nucleus is this much, and that of the fragment is this much. The total gain in binding energy in the process. Students, I'll give you a basic design of the formula here, through which we'll apply in these kind of questions and you'll get the answer easily. ठीक है? इसमें बहुत जल्दी से answer आ जाएगा. So what is the basic design? Okay, let us change again that. Let us keep now here something else. Which you want, Avatar? Well, let us keep there. Okay, this is fine. This I don't know. Okay, so I'm using this avatar now. So what I'll do is this. Dekho, here we are having a nucleus of mass number. So here we are having a nucleus of the mass number is given as 240. Okay, and this breaks into 2 subtle or subparts, which are like small n1 and small n2, and these are having mass number 120 and 120. Okay, the binding energy per nucleon of the unfragmented nucleus is this much. So if you see the unfragmented, iska binding energy is given as 7.6. By the way, binding energy is what? Binding energy is what? Binding energy is the energy which is required to break a particular materials into its sub-constitute particles. Okay, so this is 7.6 mega electron volt. This is nucleon 1, this is nucleon 2, and these are given here. Ki inka binding energy is how much? Inka binding energy is how much? It is given as, this binding energy is given as what? It is 8.5. 8.5. Okay. So what we'll do is this. So now they're asking us the total gain in the binding energy in the process is how much. So total gain will be what? Simple. Hai. You just multiply this with this, multiply this with this, multiply this with this. Okay, and then subtract these things. So let me multiply 7.6 into 240. Take a subtract minus 120 into 8.5. Then again this will be, so I will write here twice of this. The final will be your answer. Okay, so let us solve this thing. So I'll be solving this for you. Okay, just focus here. I am going to solve this. Just be focused. Very easy it is. I'll be solving it now. So I'm using calculator, just hold on, okay? Let me use the calculator to solve it and get the answer. Here is our calculator. So answer is 7.6 into 2. 7.6 into 240 comes out to be how much? This comes out to be 1.824. Okay? And 2 into 120 into 8.5 comes out to be how much? This comes out to be 2.040. Let us take a mode because we want the energy now. So if we take the mode here, we'll get the value like this, that is 2.040 minus 1.824 is equals to 0.216. So this is, by the way, mode ka aaya hai 0.216. But we want in what? These are all mega electron volts. Okay, so answer will be mega electron volts. है ना? लेकिन इसमें if you see here properly, students, this you will count it as in this value. Because okay, ठीक है? So answer will be among this. This इसमें कुछ missing होगा. You will write 216 is the answer. This is your perfect answer. Okay. So now let us see the sixth question, students. Let us move towards the sixth question. Okay. Meanwhile, let me move towards the YouTube and let's see what the students are doing there. So I am on the WhatsApp now. If I move on the YouTube, if I join the YouTube here, so let us see what's happening on the YouTube there. It's working there or not? It's working. Okay. Somebody has given the chat. Yeah, hi. Less than a minute. Who's this less than a minute? Okay, let us proceed. Let's go towards our work. Yeah. So here it's very simple. It says a parallel plate capacitor has a uniform electric field E in the space between the plates. Okay. If the distance between the plates is D and the area of the each plate is capital A, the energy stored in the capacitor will be how much? They're asking this. Suppose this is our plate. Okay. This is the second plate. This is minus here. Okay. Here, you know this thing, capacitor plates mein hota kya? Capacitor is what? Capacitor is the combination of two plates which are situated at a d distance from each other. Okay. This is having a positive charge plus q here everywhere. This is having the negative charge minus q everywhere. Okay. This is plus q here. This is minus q here. Got it? All of you. Right? So if you see here, it's given here the energy stored in the capacitor will be how much. They're asking us from this question. We know this thing, something which is known as energy density. We know something which is known as energy density. What is energy density, by the way? Energy density means energy stored in the capacitor per unit volume. This is the energy density. And its value is, by the way, half epsilon naught electric field in the electric field inside the capacitor plate plus minus the square. Now they're asking the energy. So simple, multiply this with cross multiply this. Okay, so when you will cross multiply this, energy stored in the capacitor comes out to be half E naught E square into volume. And you know this thing, capacitor plate mein volume is how much? Volume is cross section area of the plates into distance between them. This will give you the complete package, no, complete volumetric package. So this is what? This is half epsilon electric field square area of cross section into d, small d distance between the plates. This will give you the complete energy here. Okay, this is giving you what? This is giving you the complete energy. Okay, so if you see, the answer will be 4 is our option. Answer will be what? Answer is 4. I hope it's clear to all of you. I hope, students, it is clear to all of you. I hope it's clear to all of you. I hope it's clear to all of you. I hope it's clear to all of you. Okay? Let me choose. I less than a minute. Okay, let us see the 7th question now without wasting time. Okay. This is our 7th question. So therefore, this question go, it says the number of photons per second on an average emitted by a source of monochromatic light of wavelength this much, when it delivers the power of this much watt, will be how much? So students, if you haven't studied the theory, it will be very difficult for you. So what you need to do is this. You just remember this formula which is given on your screen. It says it says like this on the left hand side, the physical significance is this, or the interpretation is this: number of photons emitted per second is equals to, on the right hand side, it is given as how much? Power delivered upon, what is that? Energy. Okay? Very simple it is. So power delivered will be how much? Power delivered is given here. So just put the values and get the answer. Power delivered in front of you is 3 into 3 into 10 to 3. See, remember, what we need to do is this: we must be careful while using the units. So this is how much? 3 into 3, 10 to the power minus 3 watt. And if you see here, energy will be how much? Energy is E. This will give us our answer, n per second. Now, if you see H, which is Planck's constant given to you, and wavelength is given to you. Okay? So what we will do is this: we'll use this formula of energy, where hc by lambda can be written as, if lambda is given in nanometer in questions, so you can write hc combinedly directly as 1240 lambda nanometer. When you will put here this lambda as nanometer, you will get the energy with this direct formula, but the unit of that energy will be electron volt. Okay? But we know watt is what? What is watt? Power is what? Basically rate of doing work, energy per second or per time. Okay? Joules per second is power, or direct unit which I'm using is watt. So simple, it's in joules. So what we need to do, we'll convert this electron volt in joules. So this will be the answer. Energy is how much? It is 600. Sorry, you use the formula first of all. Here energy comes out to be 1240 upon 600 into 1.610 minus 19 joules. Okay, we'll put this value here. We know this thing 6, and this comes out to be how much? No need of this first. Let us directly solve it. So 124 into 1.610 minus 19 joules. ऊपर जाएगा So this will come out to be 60. Okay. Fine. See how the examiner have set this question. Okay. So see what you do. This and this will get cancelled. Fine. Now we know this thing. 3 1 ja 3, 3 1 ja 3. And if you see here, no, this will not cancel. Okay, let us do this. Leave this. Let me erase this part. It's a very simple calculation now. Okay. So we'll say 2 6 ja 12, 2 2 ja 4, 2 3 6, 2 0 is 0. Okay. Again, we are having here. This will be how much? 15. 2, 2. Okay. So if you'll multiply these things, okay, you'll get something which is very close. So you'll get the power of what? You'll get the remaining, you just take the powers. Because if you see the option here, these options are in the power form, 10 is to power something. So I will take the power, approx answer will be 10 positive 19, because minus 19 when goes towards up, and the numerator will become positive. And this is 10 3. So answer comes out to be 10 is to power 60. This is your final answer. Very simple. 4th is the answer, students. So the golden formula is this. You can call it a 5-star formula. If you will remember this, you'll get a direct answer in this NEET. And in this NEET 2021 question paper, all the questions were what? So all the questions were a little bit, I mean, most of the questions, more than 95, 98%, 96 and 7 approx were formula based. Okay. Let us move next. This is just a theoretical question. It is judging your theoretical conceptual clarity. Okay. So it says here the polar molecules are the molecules. Options are this. We know this thing. Polar molecule looks like this, plus minus. So it's 100% sure it is having permanent electric dipole moment, plus minus. So first is the answer. Second, zero dipole, no. Polar में zero का कोई sense नहीं, it's non-polar, no otherwise. Zero dipole non-polar होता है. Acquired dipole moment only in the presence of electric field due to displacement of charges, no. It has already naturally acquired it. If it's a polar, if you put an electric field, it depends. What are the more if there's more separation, okay? It's such like that key. It has been kept from positive to negative. If they are coming closer, it's a very difficult, critical kind of case. Okay, acquired dipole moment only with magnetic field. This doesn't make sense. So the answer is first, having a permanent electric dipole moment. Okay. Next question is this, which says, I'll read this question for you, students. Okay. It says like this: the half-life of a radioactive nuclide is 100 hours. So this is from a radioactivity chapter. If you see, there are some elements we have seen in the periodic table also. At the bottom left, right corner also, on the left also, there is kind of, a column 2 row. It's like, if the column is like, 2 into several times. Okay. So these are all radioactive elements. So it's given here the half-life. So T half is given here 100 hours. Okay. The fraction of the original activity that will remain after 150 hours will be how much? Activity is something we know this thing actually. I'll not tell the physical significance, but you must remember the formula. The activity is like this. The basic activity, I mean the initial quantity remaining, original one, upon twice raised to power. What is that? What is this? N. N value will be found out from this. This is what number of? What is this number of? This is the number of part of that radioactive element remaining. Okay. So see what we'll do is this. It is given here the half-life given. So half-life we are having T half according to this formula. Capital T they are saying the fraction of the original activity that will remain after 150 hours. So this capital T is 150 hours, which has been asked from us. This will give us the n number of that. Okay. So we'll put here the values. It's formula based. It's very formula based. So n will get as 150 upon T is what? 100 hours. 100 ka half we will do here. Okay. If you solve this, students, what you'll get? Any one of you? How much answer will you get? Any one of you? ठीक है, so solve करो. This will give you 100 का रूट कितना होता है? Square root 100 is what? 10 into 10 is what? 100. 10 square is 100. No, root क्या हुआ? 10. So this will give you n15. ठीक है, in front of you. So just put this n15 in this. Final activity remaining. Original activity twice of n is 15. ठीक है. I think there is some mistake here. No, hold on. I did some mistake. इसमें fraction ही लगेगा. By mistake I put here the fraction value. It's just t half. T half is actually 100. Okay, 100. So this is 1.5. We know this thing 1.5. If we see the number properly, do some modification in this. This comes out to be 3 by 2. So n value which I'm getting here is nothing but 3 by 2. Okay. So final answer will be this. That is A, which is the final fraction of the radioactive element remaining. Original fraction, initial whatever it was, upon 2 by 3 by 2. Now 2 raised to power 3 by 2 is how much? It is square root ka cube. So this comes out to be root 2 is 2 root 2. So this is 2 root 2. So we are having A value comes out to be A naught by 2 root 2. Okay? A naught by 2 root 2. So we'll say here 3 is our answer. Okay? So final answer comes out to be 1 by 2 root 2. Okay? I hope it's clear. Let us proceed next. 10th question. So now we are here at the 10th question, students. I hope it's visible to all of you, all of you, all of you, all of you. 10th question says what? It says a capacitor of capacitance C is connected across an AC source of voltage V given by V equals to V naught sine omega t. Displacement current between the plates of the capacitor. Suppose you're having a capacitor like this. This is plus Q minus Q. Plus, minus. Electric field comes out from here to here. This is electric field. The displacement current between the plates of the capacitor will be given by what? Therefore, we'll use here the analogies of what? You may have seen CCE, that current is what? Current of the capacitor is, it leads. Okay, current of the capacitor what? It leads here. Okay, so very simple. Displacement current they're asking. Kya karo? We know this thing. Maximum current amplitude is given by maximum voltage upon impedance. But here, when there is just, it's not a LCR circuit, it's not a LC circuit, it's not a LR circuit, it's just purely capacitive circuit. So such kind of circuit which is given in this question is basically purely capacitive circuit. This is what? Capacitive, purely capacitive circuit. These are purely capacitive circuits. Okay. So maximum current amplitude will come out to be, voltage is how much? It is V naught. Impedance. Impedance in purely capacitive circuit, remember it is always given as, what is that? XC. And XC is how much? It is 1 by omega C. So when I will put this here, I'll get 1 by omega C. So I can comment from this, maximum current amplitude which I am getting is, this is equals to omega C V naught. And now it's very simple. We know how the equations are. These are sine equations. Okay. And also we know this thing that current leads the voltage in purely capacitive circuit by the phase of pi by 2. Remember this thing? The current leads the voltage in purely capacitive circuit by pi by 2 degree angle. So the equation becomes how what? The equation is this now. That is, current equation will be I naught max or I naught, you can write. These are just the subscripts. Sine omega t stands for the phase of because omega t is what? It's basically theta only. Theta equals to omega t. It's a phase of voltage. Current leads by pi by 2. We know this thing sine pi by 2 plus theta is how much? It's cos theta. So this is I know next. This is cos omega t. So I will use this. Okay. So from here, if I put here this value, I'll get as what? I comes out to be omega c v naught. Okay, this is cos omega t. Okay, so if we see the equations, this is our answer, by the way. This is our answer. Okay. So we see the answer comes out to be omega c v naught cos omega t. So options can omega c v naught cos omega. So displacement current here comes out to be this. According to the equation, the formulas, we're going to see cos omega t. Second is the answer. It's a perfect answer. Okay. Let us proceed next. So now this is the 11th number question, by the way. Okay, this is what 11th number question. It's screw gauge question. Let's ask you, a screw gauge gives the following readings when used to measure the diameter of wire. Suppose you are having a wire and they're asking you to here measure the twice r, that is the diameter of this wire, by using some screw gauge kind of system. Okay. The main scale reading is given as 0 millimeter. So it's very easy now. Circular scale reading is 52 divisions. So that will work. And it's given here that 1 millimeter is 100 division. Okay, so if 1 millimeter is 100 division, 1 division will be equals to 1 upon 100 millimeter. So 1 division comes out to be, it's very easy question, 1 by 100 millimeter. Okay, so now we need, there are how many divisions actually? 0 plus 52, total divisions are basically 52. So multiply this with 52 division, this will give us in millimeter. Okay, so the answer is 0.52 millimeter. So now if we convert this, diameter will come out to be this one. If we convert this 0.52 millimeter in centimeters, milli is 10 minus 3. So this will give us 0.052 centimeter as the answer. Answer is first. Very easy, straightforward questions. Okay. 12th question, students. It says, find the value of the angle of emergence from the prism. Refractive index of the glass is √3. So here the refractive index of the glass material from which this prism is made is √3. Mu is √3. It's been kept in a surrounding medium which is air. That is 1. In all the sides, it's 1, 1, 1, 1. Okay. Now they say, suppose the rays coming like this. Remember, we always take the angle of incidence from the normal direction. Here the normal ke saath it's parallel. So angle of incidence will be 0. If angle of incidence is 0, from the Snell's law, which is n1 sine I equals to n2 sine R, we'll get, if I is 0, sine 0 is 0, it means left hand side equals to right hand side, R is 0. Angle of refraction will comes out to be what? It will be 0. Okay. So now when this will enter here, remember, we know this thing, R1 plus R2 is equals to angle of prism. Suppose R1 is ka refracting angle and R2 is a refracting angle when this ray emerges out of this. See, R2 is this. Suppose when the ray enters here, no, if normal is this, R2 is entering like this. So this is suppose R2 here. Okay. So emergence ray will be somewhat away from the normal, hai na? Because it's rarer medium. This is E angle. This E angle they're asking us to find. Okay. Ye relation hame pata hai. Remember, angle of prism is what? It's not 60 degrees. It is not 90. It is the angle between the two refracting surfaces from which the ray is refracting, entering and passing away. So this will be the angle of prism. We know the property of the triangle is what? The property of the triangle kya hota hai? What is the property of the triangle? Property of the triangle is given as 180 degree is equals to angle of prism 60 degree plus 90 degree. So this 9, 10, 11, 12, 13, 14, 15, 180 minus 150 angle of prism 30 degree is the angle of prism. So put here 30 degree angle. Okay, angle of prism comes out to be what? 30 degree. 30 degree. But here R1 value is what? It's 0. This is I, this is R1 from the first surface. This is the second surface. R1 is 0 already. R2 will comes out to be equals to A, that is 30 degree. Simple now. So on this perpendicular surface, we are having R2 value, which is 30 degree. We are having this angle of emergence value. We are not having actually. So we'll use Snell's law. It says mu of glass, mu of air. It says mu of glass sine of R2 equals to mu of air sine of E. Mu of glass kitna hai? It is, we know the glass value is how much? What is the refractive index of the glass? What is the refractive index of the glass? Refractive in the glass comes out to be how much? Air का कितना होता है? It's 1. इसमें कितना होगा? Anyone? Okay, let me search. It's 3/2 by the way, but still I'll confirm. Sometime, you know, I get forgot here. So this is chrome. Glass refractive index 1.52, approximately 3/2. It's fine. Okay. So glass का refractive index होता है 3/2. 2 into 2, 2 has a 10, 1.5. Sine of R2 is 30 degrees. Sine 30 is, we know, half. And sine E. So this is half, this is 3/4 sine E angle. Okay. This will be how much? Anyone can comment? You see the options. ये तो नहीं होना चाहिए. Can anybody comment on the answer? What is the answer, students? Oh, here it's given the refractive index of the glass is √3. We can't take that. Actually, it's 1.5. Always will find on the Google. Okay, on the Google you will find it to be like 1.5, 3/2. But here it's given √3 already. That's why the answer is different. Otherwise, the answer is right. Officially, the answer is right. But as per the question, we'll not take this answer. This is √3 given in the question. So the answer comes out to be √3/2. And angle of emergence sine inverse root of 3/2 is how much? Iska sine theta √3/2 hota hai. It is 60 degree. So the angle of emergence we are having as perfect answer comes up to be 60 degree. Okay? So this is an answer. Let us proceed. Now I'll be fast a little bit. In the potentiometer circuit, a cell of EMF 1.5 volt gives balance point at 36 centimeter length of wire. If another cell of EMF 2.5 replaces the first cell, then the what length of the wire the balance point occurs. Remember always that EMF is proportional to this position X. Okay? So first, let us make a table. E1 is given as 1.5 and the balance point X is given as 36. When EMF is replaced by 2.5 voltage, a new balance point will be, because these are 1 subscript, so I've given 1 and second for the second case, will be how much? Just divide both this because these are proportional relation, directly proportional relation. So we'll get E1 by E2 as X1 by X2. E1 is 1.5, E2 is 2.5, X1 is 36, X2 comes out to be 36, 2.5 upon 1.5. The answer will be 5 3 is 15, 5 5 is 25, 3 1 is 3, 3 2 is 6, 5 2 is 10, 60. The answer is this. Students. That is 60 will be the balance point of the wire when the EMF is replaced by 2.54 from the 1.5. 60 second is the answer. Second is the answer. Okay. 14th question. A particle is released from the S height from the surface of the earth. Okay. At a certain height, its kinetic energy is 3 times its potential energy. The height from the surface of the earth and the speed of the particle at the instant are respectively what? Students, very easy question. It says, suppose initially the particle is at S height. Here I'm throwing this particle, boom, I'm dropping it. Now it's dropped. When it reaches at a particular height from the surface of the earth, let us assume it to be h height, small h. It is having, of course, if you throw something like this, when you catch it, before just catching it, it is having some speed. What's the reason it is having some speed? The reason is this: the potential energy at the top is getting converted into kinetic energy at all the steps until this particle reaches where? This particle reaches to this surface. Okay? This particle reaches to this surface. So we'll say here that initially the potential energy, also it's given here that at this point, the kinetic energy is 3 times the potential energy. And we know at this point, if I mark the level, the potential energy is mgh. And if I see here, the kinetic energy is 3 times mgh. Okay? Finish. And here, the potential energy is mgs, kinetic energy is 0. This is the potential energy. Okay, let us use energy conservation laws and find the answer. So energy conservation law says like this, that at this level, the converted potential energy is mgs minus the level only, that is mgh, this much part is converted into kinetic energy, or the part of the potential energy extracted and being converted. Half mv square. Okay. Okay. Also, it is given as that this half mv square at this level, that is at this level, is equals to 3 times the potential energy at that level. Matlab, it is equals to 3 mgh. Okay. So we'll use both these equations and find the answer. So we'll get like this, that is mgs minus mgh is equals to 3 of kinetic energy, that is 3 mgh, 4 mgh, mgs, mg cut, s by 4 is the height. So we get the height as height at the from the surface of the earth where this particle is at a point where the kinetic energy is 3 times the potential energy is s by 4. Okay. What is the speed at this point? Very simple. So s minus s by 4 gives you the converted distance, that is 3 s by 4. This will be the potential energy, that is mg 3 s by 4 equals to half mv square. This gives you the answer as v comes out to be 3gs by 2 ka under root is the speed which is converted here. This is a speed. Okay. So s by 4 and under root 3gs by 2. First is the answer. S by 4 and under root 3gs by 2. 15th. What will be 15th? The effective resistance of a parallel connection that consists of 4 wires of equal length, equal area of cross section, and same resistance. So basically, they are saying like this, that you are having 4 wires which are having their resistances connected in series. Parallel connection. I'm sorry. So the connection is like this. All the resistance are having the same value, but they are connected in parallel to each other. Okay, effective resistance comes out to be, we know when the resistances are connected in parallel, then it is how much? 1 upon r net is 1 upon r, so it is 4 by r, so net is what? I'm writing directly r equivalent or effective is r by 4. ठीक है, इसका वैल्यू दे रखा है in the question is 0.25 ohm. They're asking if we if we just modify the circuit and we just use, we're not changing these r values, we will connect just this r values in the series format. So what will be the new effective resistance? We know this will be actually 4r because series में add हो जाता है r1 plus r2 plus r3 plus r4. Simple है. So from here find the value of r. This is how much? 4 for the 20, 4 to the 10, 11, 12. This is 1.2 something r value. So multiply by 4. When you multiply by 4, this will give you 4.8 ohm. ठीक है? Something 4 ohm. Am I wrong here? Correct. What's the issue? Oh, sorry, it's 10. 1.2 में 1 है. This is 1.0. So this is 1.0. This will give you 4 ohm as the answer. So the net answer is 4 ohm. Okay. 16th question. It says water falls from a height 60 meter at a rate 15 kg per second to operate a turbine. You know the turbine system, how the electricity generates through water. So 60 meters say, let us make a good diagram. 60 meters say water is falling. So what's the height is? Height is 60 meter. Okay. At the rate of 15 kg per second to operate a turbine. So it falls at a rate of how much? 15 kg per second. The losses due to frictional force are 10% of the input energy. Remember here, the speed is given, massive speed. Okay. How much power generated? It's very easy to use. Power is what, by the way? If you see the power value, power is rate of doing a work, energy by time. Okay. Energy here is completely as how much? क्या energy? What is the energy here, students? If you see here, what is the energy? Anyone? So we'll write this kg second per is how much? It is actually mass per second. है ना? So we'll do what? We will use here mgh by time. If you see the units, just from the formula, just do some extraction. M by t is how much? It is giving you this thing, mass flow, 15 kg per second. Kg is 1000 per second. It's gram per second. Okay, give it. You can make kg also, no issue. I'll find the answer very simply. 60 meter is the height. 10 is that 10. 60 meter is the height. And 10% of the input energy. So 10% कितना होता है? That is 10 upon 100. Multiply this. So we'll get the answer. This is again gone. So if you see here, the answer comes out to basically, let us keep this in kg, kilo only. Let's keep this kilovolt because kilo is 10 to the power 3. So this will come out to be 6, 5, 30, 90, 900 kilo. Okay. It's coming out 900 kilos. Okay. So this is coming, the answer is like this. You have to check this answer. Hold on. Okay, maybe the G's fine, it is used at 10 only here. So 10% of the energy is converted. Losses due to friction force at 10% of the input energy. 10% of the input energy. So let us find something. 10% of the input energy. So if this is the input energy, it's got 10%. Matlab 10% will be this much. Remaining energy will be losses due to friction for the 10% of the input energy. How much power generated by the turbine? So power generated will be tog as like this, will minus this. Answer come out to be 90 upon 100 E value. Okay. This is again coming as something else. Yeah. So we'll multiply this with this value. 90 upon 100 will give us the value as 81 something kilo. Ultimately, you'll find the approximate answer to be like this. Yeah. So you can put here 8.1 also. Okay. Meter you can convert in kilometers. So this height is 60 meter, you can convert in kilometers. This will be something 8 point something. Okay. If there is some change in answer, I'll confirm you via PDF. So 17th number question, it says what it says. Very simple. I'll just directly explain you because it's time to wrap up. Okay, we'll just end up the class. So this is basically, students, it says infinitely long straight wire carries a current 5 ampere. So this is both the sides, it's infinitely long. It's plus infinity, it's minus infinity. Okay. So 20 centimeter from this is r distance, 20 centimeter. We know due to infinite long wire, magnetic field at any point which is at a r distance from the wire will be how much? Wire say r distance per point kitna hoga? How much it will be? It will be equals to mu naught I by 2 pi r. Mu naught value is 4 pi into 10 minus 7. Current I value is 5 ampere. 2 pi is how much? 3.14. R is 20 centimeter. 100. Okay. This is how much? This is magnetic field intensity. ये क्या है? ये magnetic field intensity है. ठीक है, समझ में आ गया. Now what's the next thing? Now they're asking us what is the force experienced by that electron which is moving with speed 10 is to power 5 meter per second parallel to the wire. So very simple. It's making 90 degree with a distance. It's QVB force, which is QVB. V cross P cross sine 90. How much? 1. Sine 90 degrees. How much? 1. So QVB. Put the values. Q value comes out to be electron पे charge होता है 1.6 10 minus 19 coulomb. Velocity is 10 to the power 5 meter per second. Magnetic field is this much. 4 pi into 10 minus 7 into 5 into 100. Denominator पे 2 into 20 into 3.14. ठीक है. So now I'll be solving in front of you this on a calculator. Let us find the answer. So the answer comes out to be 1.6 into 4 into 3.14. See, this and this is already cut. No need of this. Yeah, we can solve, I think, without the calculator also we can solve this. है ना? 4. This is 10. This will be 10 is to the power 4. Okay? This is 5. 6 5 the 30s. 5 and 5. 9. Okay? This is 19, 20, 21, 22, 23, 24, 25, 26. This is 10 is to the power 4. 10 is to the power 6. 9 into 10 is to the power minus 20. Okay? So answers will be actually at in the form of, this is 8, sorry, 6 of the 30, 6, 7, 8. So 10 minus 8 raised to the power 10 minus 20 Newton is the force. So answer is first. Very easy, very well simplified. Pi factor नहीं रहेगा. देखो pi यहाँ भी और यहाँ भी. It will go. ठीक है? Next, again a theoretical question which checks your theoretical concept clarity. Okay. So it says, first statement is a Zener diode is connected in reverse bias when used as a voltage regulator. Of course, it's sure. Zener is what for? Reverse only. Next is this potential barrier PN junction lies between 0 to this. This is doubtful. Why? Because if you see the NCERT, if you increase the voltage, the graph breaks here at something at 0.6 voltage. It's something like this, 0.6 voltage or something like this, whatever. So value is 0 at 0.6 voltage, which is exceeding this 0.1. Okay, which is exceeding what? Let me check somewhere. Which is exceeding this 0.3 volt. So first is true, second is wrong. First is true, second is incorrect. Fourth is the answer. Okay. Yeah, this is again very easy. I just directly solve it. Say the spring stretched by 5 centimeter by force 10 meter. So this is a spring. It's stretched by 5 centimeter. Force is 10 Newton. It is Kx. X is 5, K comes out to be 2 Newton per meter, spring constant. And the time period of the oscillation when a mass of 2 kg is suspended, suppose 2 kg mass is suspended. Remember students, always in the case of spring and the mass, spring block system, if it is suspended like this, it is doing SHM, plus minus plus y plus minus y plus minus y. It is suspended like this. It is doing SHM plus minus x, whatever. The time period is always 2 by under root m by k. This is the time period. Okay? So this is 2 pi under root m. Mass is how much? 2 kg. K is how much? 2 pi. So time period comes out to be 2 pi. So 2 pi approximately is how much it is? 3.14. 2 this is 2 4 this is 6.28 second. This is 6.28 second. Okay. That is the option. This is how much? 6.28 second. Got it? Yes. Now let us see the 20th question. Again, theoretical aspect. And it's asking your conceptual clarity again. So remember one thing, students. They're asking you basically the current will be where high? In the P side or in the N side? Okay. We know the equation of the current which is given here at the right bottommost corner. It says like this: I current is equals to number of charge carriers per unit volume, electron area of cross section, and drift speed of the charges. Remember, electrons are lighter. Electrons are what? These are lighter. Mass kitna kam hota? 9.110 is minus 31 kg. Minus 31. It's very less amount. It's very it is at the microscopic level. Okay. And if you see the drift speed, lighter the mass, more the drift speed. So more the drift speed, more the current. So we'll say N side, which is what? Electrons. P for the for proton. Like it's not proton, basically it's holes. Okay. So N for electrons are having more drift speed. So they will be having, due to this formula, as per this formula, they will be having more current. So N side is having more current. So current in the N type is more as compared to the current in the P type when they're kept in the external electric field. Remember this. Okay. 21. This is students, they're asking a dipole is placed in an electric field as shown. This is a dipole and it goes from plus to minus is the electric field. They're asking in which direction it will move. See, electric field is in all this direction. Electric field is here also. Electric field is here also. So where it will move. Remember, we also know a formula, a relation, that is U is minus of P dot electric field. So it is having negative proportionality relation between the potential energy. Okay. So when we go from here to here, electric field is basically decreasing or increasing. If you see here. See, if I'm keeping this dipole here, if it is moving in this direction, so electric field is from here to here. Okay, so they're asking where it will move. So it will move in such a direction. Okay, so you can see like this also. We can compare this with mechanics analogy. It says suppose you drop a block from height like this to the bottom floor. Here the potential energy is max. Here the potential energy is 0. So if you go from higher potential energy to lower potential energy, speed increases. Similarly, when you go from high electric potential to lower potential, what's going to happen? When you go from higher, we also know one formula, that is electric potential is inversely proportional to 1 by R. So when R increases, electric potential decreases. Okay, so we'll say as you go from higher potential to lower potential, okay, so we can comment like this, that electric field decreases there, symmetric there, okay, because R is less, you are near to the charge, potential will be more. R is greater, you are away from the charge, potential will be less. So from higher to lower potential, electric field intensity amount is decreasing. Okay, so it will move in such a direction where, which is direction of higher electric field intensity to lower electric field intensity, where the potential energy or potential decrease, because potential energy is somewhat approximately to potential electric potential. Okay, so it will move in such a direction where potential energy will decrease. So the answer is this, towards the left where the potential energy will decrease. Okay. Next question is this: a convex lens A of focal length 20 centimeter. Let us draw fast behind the glass. This is convex lens having the focal length 20 centimeter and a concave length B of focal length 5 centimeter. This is concave. Let me draw it more properly. It doesn't look good here. So this is concave length. Okay. Focal length 5 centimeter. Okay. Are kept along the same axis with a distance D between them. Okay. So parallel beam of light is falling on A, leaves B as a parallel beam. So they are saying what must be the case such that when these two lenses, that is one is convex and other is concave, when kept together, having a separation distance between them is D, such that when the light parallel beam passes from the left of the convex lens, it must go right of the concave lens as consistently parallel. I mean, if we see here, if it is parallel here, it must go parallel here. In between, anything can happen. So the case will be like this. These rays, if these are parallel to the convex lens, it will be converged at the focus. Focus here is at 20 centimeter. And this focus, remember, this focus of the convex or converging lens must superpose. This focus of the convex lens or converging lens must superpose with the concave lens here. That is the diverging lens. And concave lens ka kya hai? What was the reason? Because remember, whenever you keep an object on the focus of the diverging or concave lens, the rays which will pass out from the other side will be parallel. And that is satisfying the demand of this question. So the net answer will be 20 plus 5, that is 25 centimeter. Okay? Answer is 2. Let us move next. Very easy. It says the escape velocity from the Earth's surface is V. We know the escape velocity formula is under root 2gm by r. Okay? This is given V here. Okay. The escape velocity from the surface of another planet, maybe something around Jupiter or some hypothetical planet, having the radius 4 times that of Earth, have same mass density, is how much? Simple. So the radius of the other planet is 4 times the radius of the Earth. This is r for Earth. This is for Earth. So mass density is same. Density is mass upon volume. Mass will be density into volume. Let us put this formula here. Okay. So velocity comes out to be under root 2g density into volume upon r. This is speed, this is volume. Okay. Now they're asking what will be the escape speed. Symbol escape speed at a particular different planet will be twice of the mass density into volume of the planet. Okay. And radius of the planet. Radius is radius of the planet. We know it's given in the question, radius of the planet is 4 times the radius of the Earth. Put the value here. So this comes out to be 2g rho. Volume is, it's volumetric planet. It means spherical planet. So we'll write 4/3 pi radius a cube. That is 4 into 4 into 4 r e cube. Okay. And the denominator, the answer will be 4 r e. So when we will solve this, we'll get the value to be 2g 4/3. 4 and 4 will cancel out by r e. Okay. Into 4 into 4. This will cancel out with this r. Okay, r e square, no, it's cube. So this will give you square. Okay, fine. So this is your answer. But if you see the options in the V sense. So if you see the volumetric relation, students, let us check it out. So this is 4.3 pi r cube. So this will be r square. This is same here. This will give you the mass. Okay. Okay, let us not include this thing. Leave this. It is creating a problem for us. Remember one thing. Volume is 4.3 pi r cube for a sphere. Okay, it's proportional to r cube. So volume of the planet will be how much times? Volume of the earth cube. It will be 4 cube of the volume of the you see. If it is 4.3 r cube, yeah, it is 4 cube of the volume of the earth. Okay. So this is the volume of the planet. So put the values and get the answer. Put this value here, put this value here. So the answer comes out to be 2g rho. This is 4 cube volume of the earth. This is the volume of the earth. This is the radius of the earth. This is 4 times the radius of the earth. So answer comes out to be, this is 4 square. So answer is Vp 4 under root 2g rho VE RE. 4V is the answer. So the escape speed at a planet, another planet will be 4 times the speed of the earth. That is the escape speed of the earth. So the answer is first. Okay. So students, now it's time to end the class with the last question. That is not the last, it's the second last question, I think so. Yeah, second last. Last is the simplest. So again, it's very easy. It's like a photoelectric, but not a photoelectric. It says like this: you are having some metal plate on which some electromagnetic wave falls like this, but there is no work function defined for this metal plate. So photon, so electron, see, this is a photon. Okay, it's having some energy at c by lambda. Okay. This complete energy, since there is no work function, so none of the part of the energy will be deleted. So electron comes out with the complete whole packet of energy, that is which is the photon is having. So it comes out with the energy which is hc by lambda. They're asking us that lambda d will be how much? Okay. And lambda d. Electron, photoelectron का lambda d कितना होगा? Okay, lambda d. Simple as students, very easy. Remember, wavelength दे रखा है photon का. So we are having energy of the photon as hc by lambda. ठीक है? This energy will be completely converted into kinetic energy by this photon. ठीक है? So lambda d approximately will come out to be. First of all, let us see the speed. Or let us make the formula. Formula is this, that is h upon under root 2m kinetic energy. Okay. Let us make it lambda d. So if my kinetic energy put for this much. So if you put this kinetic energy here, okay, again it's coming complex. This is to make it complex terms. Okay. So lambda d comes out to be h upon 2m kinetic energy. This is hc by lambda. So this comes out to be lambda d. Root will cancel out. So this will be under root twice of m c lambda. Just square the values both the sides. So lambda d square h lambda by 2mc. So we will say the lambda is this. That is lambda is 2mc by h. This is how much? 2mc by h lambda d square. Lambda d square. This is the answer. So let us check the options. 2mc by h, 2mc by h lambda d square. This is the answer. Perfect answer. Okay. So here our 24 question is solved. Now let us see the 25th number question. It says a lens of a large focal length and large aperture. Large focal length का मतलब at a particular lengthy range it can focus. Long aperture मतलब long object, a large aperture or large objective sense means what more number of rays can come inside. Is best suited as an objective of an astronomical telescope since large aperture contributes to quality of the visibility of the image. Yes, if the aperture is large, objective is bigger, the more number of rays can enter. So we can see a best, more precise image. Quality is, yes, it's fine. Large area of the objective ensures better light gathering power. That is also fine. More number of rays will come, be able to see, consider the image on the, maybe on the computer screen in a more better way. Large aperture provides a better resolution. Yeah. If quality is better, resolution. See, you have seen the wallpapers 1240, 360, 480. So if you see the YouTube videos also, if you see at 2040, 1080 pp, the resolution is so much greater. It's so much fine and precise. So you feel like it's like going real. It depends upon screen to screen, device to device. Answer is all of above. Okay, this is the answer. So students, we have solved in this series approximately, we have solved actually, not approximately, completely we have solved 25 questions today out of 50 questions in this Neet 2021 paper. Okay, next class we'll solve the remaining 25 and that will complete our 50 by 50 happy marks. Okay, so that was all about today's class, students. So we'll meet in the next class. Till then, bye bye, best of luck, study smart and work hard. Okay, and subscribe this channel. Okay, so I'll give you this these notes as a PDF in your group. Okay, bye bye. Now you can leave the class. Bye bye, everyone. So we'll meet in the next class. Okay.